Okay, grade 8, we're now going to be doing parallel lines, alternative angles, right? It's very important to know that what we have done in the previous videos, especially with the introduction to parallel lines, what is a transversal line, what are the different types of angles, and we previously had done corresponding angles, and now we're going to do alternative angles, another type of angle you get when a transversal line crosses a parallel. Okay. If two lines are parallel, the transversal line is the one that crosses both of them, right? You know this. We have a parallel line and a parallel line. We indicate these are parallel by these two arrows here. As you can see, these arrowheads, each are one arrowhead. That means that they are parallel. We could, of course, have put two on each, and those would have been the same. They are parallel. And then the transversal line crosses the two parallel lines. When the transversal line crosses, there will be four corners. These corners are A, B, C, and D. As you can see, there's 1, 2, 3, 4 corners. There will also be two identical sets of corners. Now, this is the amazing thing about a transversal line across parallel lines. The two sets of corners will be identical, E, F, H, and G. So A equals E, B equals F, C equals G, D equals H. And this is what a corresponding angle was what we learned in the previous video. So what else isn't nice about this? Let's look at alternate angles, right? An alternate angle is either interior or exterior, right? So what do I mean by that? An interior angle would be D and F, or C and E. So what D and F, these are alternate interior angles. They're on the interior of the two parallel lines, they're on the inside of the two parallel lines, and they're alternate. They're on different sides of the transversal. Another one is C and E, and here we have C and E. Again, these are alternate interior angles. What about alternate exterior angles, right? So now an alternate exterior angle, alternate, they're still alternate, meaning they're on different sides of the transversal, but they're now exterior, meaning they're on the outside of the parallel line. So we could have A and G, or we could have B and H over here. These are alternate interior angles and alternate exterior angles. Let's look at this example. Find the following alternate exterior angles here, and then we're going to find the following alternate interior angles. Okay, G and what? So let's first find G. G we're going to put a square around. Okay, what can G be an alternate exterior angle with? So it's got to be on the exterior of the parallel line. So we're obviously talking about this line because this is on the outside of this line, whereas this one, it's on the inside of this line. So we have G on the outside. What is alternate? It's on the other side of the transversal, and it's on the outside of the line. So it's going to be G and A. What about B? B, again, should be quite easy, is an exterior alternate angle. Here it is, H, B and H. What about E? Now E, let's put a triangle around E, is an interior angle of these two parallel lines. But of these two parallel lines, it's an exterior angle. And here is the transversal. So we go to the other side, so we go alternate, so it's exterior, it's on the outside, and alternate, it must be O. So E and O. You see how it made this little Z here, E and O. Okay, let's now look at U. Where is U? U, we have found U. We're going to put a circle around U. Now, where is the alternate exterior angle? So we have a parallel line and a parallel line. So this is our transversal. So we've got to look at this section here. So U is an alternate exterior. So it's exterior. Yes, we see. It's alternate. It must be S. U and S. I, where's I? I is here. So we're going to put a square around I. Now, I here is an internal angle if we look at these two parallel lines, but it's an external angle if we look at these two parallel lines. So we're going to have to look I over here, and then we can see it's the same as that O over there. So I and O. Great. Find the following alternate interior angles. Now we're looking at interior angles. F. Where's F? F is here. Let's put a square around F. So it's got to be interior. So it's on the inside, and F could be on the inside over there and on the inside over here. So we could make F either D or P. So F can be D and P. What about C? Let's look at C. We put a circle around C. It's an interior angle for both I and E. So C can be for I and E. So what is E? So we have E is an exterior angle for these two. Let me actually rub a little bit of this out because it seems to be getting a little bit out of hand. So we have E, and E is an interior, it's an exterior angle for the two parallel lines shown going here. So we can see that E is exterior here, but is E an internal angle here? So we want an internal, alternate interior angle. So alternate, the other side, interior on the inside. So it's C. So E and C, but that's the only one. What about I? Let's look at I. We put a circle around I. Now I is an external angle if we look at these two, but it's an internal angle if we look at these two parallel lines. So it will be I and C. I and C. What about our last one, X? Let's put a square around X. Right, for X to be an interior angle, it must be with these two parallel lines over here. This is the transversal. So we have the inside of that, we go down to there, and we can find that that answer is Q. Okay. So this was parallel lines, alternate angles. Well done, grade 8. We're now going to move on to co-interior angles, the last one in geometry of straight lines.